This is Mr. Herman. In this video, we will be looking at a couple of proofs and practicing applying our properties that we know, our similarity theorems, in order to prove that triangles are similar, given some figures. So you've done proofs before with congruency, and it's pretty much the same idea. We have our statements on the left, our reasons on the right, for when we're doing two-column proofs, and we always want to look at our given and look at our figure first. So in this case, we are told that AE is parallel to BD. AE and BD, those are parallel, as we can see with those arrows there. And we're asked to prove that triangle ACE is similar to triangle BCD. So what we want to do is we want to start off with our given. Okay, so our given statement is that AE is parallel to BD, and that is given. Okay, always get to start off with the given. Now we've got a couple ways we can go here. One of those is we want to think about similarity. We've got either angle, or side, or side. Now, since we don't know anything about the sides here at all, at least not lengths is what we need to know, lengths for proving similarity. So we want to try to prove angle similarity. Okay, so we're thinking about angles that we can show that are congruent to each other. Now, the first one that I'm thinking of might be the last one that you think that we have to prove, but it's that angle C. Okay, in our video before this, we talked about our basic properties of proofs, and this is the one that we often miss. Angle C is congruent to angle C by the reflexive property. Okay, now I'm going to go ahead and label that on our diagram just to make sure that we see that we called it that. So there's our angle right there. Okay, so we've got angle C congruent to angle C. That one is good to go right now. Now let's go ahead, let's do an angle, let's go to statement 3. Okay, so if you're looking at our image, we've got two parallel lines and then a line that crosses it here, a line that crosses it there. So we want to think about some of our properties of angles when we have two parallel lines with a transversal, and in this case we're going to have some corresponding angles. So we've got angle CBD, just a quick reminder, the middle letter of an angle is the vertex. Okay, so we have CBD is going to be this angle right here. And then that's going to be congruent to angle BAE. We can come on the other side. So we have angle CDB. Angle CDB is congruent to angle DEA. And that is by corresponding angles are congruent. Okay, now let's go ahead and label that on our diagram just to show that we've got that. Now you might be thinking, well, Mr. Herman, couldn't we have just done the corresponding angles are congruent and not worried about reflexive property because we only need two angles if we're trying to prove similarity? And Mr. Herman would say, yes, you're correct. But if we prove a third angle congruent by another way, we might as well put it down there. Okay? Never bad to show what we know. Okay? So now we've got three pairs of angles that are corresponding, and they are congruent, which means that we have enough information to call these two triangles ACE similar to triangle BCD by the angle similarity theorem. Okay, and so that has been proven. Okay, so we went ahead and proved what we needed to prove here. All right, now we're going to take a look at another proof for similarity. Okay, so we are once again given that two sides are parallel. We have AB and DE are parallel. So let's go ahead and label that on our diagram. Sometimes it comes pre-labeled, sometimes it doesn't. Okay, now we need to prove that triangle ABC is similar to triangle EDC. Okay, so once again, we're going to think about, do we want to do angles or sides or both? And since we have no side lengths given, we're not going to look at side lengths. So we're not going to think about having sides in any of our theorems. So we're only looking for angle here. Okay, now in the previous proof, we thought, well, Mr. Herman, we didn't have to use the reflexive property. And so we're going to take that knowledge and try to not apply it here, but we'll see where it comes in. So let's first start with our given. Okay, AB is parallel to DE. And then our reason is given. Always a good place to start. Get that first one out of the way. Let's see. So we've got parallel lines. We've got angles inside the parallel lines. Here's our parallel lines. And a line crossing through, a line crossing through. We've got angles inside those parallel lines on opposite sides of the transversal. So those will be, I'm going to go and put our reason down here first of alternate interior angles are congruent. Okay, now let's go ahead and find those ones on our diagram. So we've got angle A and angle E. Okay, nice and quick there. Angle A is congruent to angle E. Let's go ahead and mark that as well. Angle A, angle E. Cool. And we've got those ones that are alternate interior angles. We also have angle B and angle D that are alternate interior angles. Okay, we'll label those as well. All right, and I went ahead and wrote those down in our statement column as well. So you got angle A congruent to angle E, angle B congruent to angle D, by alternate interior angles being congruent. And we said we want to use angle-angle similarity. Well, we've got one angle, we've got two angles, so we're ready to go. We're good to go. We can go ahead and make that final proof statement. So we're going to prove that triangle ABC is similar to triangle EDC. And based on what we have made in our statements, we have an angle and an angle. So we're going to call angle similarity theorem. All right. Now, you might be asking, well, Mr. Herman, could we have said that the... let's look at this angle right here. Angle C. I want us to talk about it even if we're not necessarily including our proof, just so we can remember what it's called. But this angle right here, angle ACB is congruent to angle ECD. Okay, we're going to make this claim. We'll make it number 4. Angle ACB is congruent to angle ECD. Since they're across from each other, that is a vertical angle. Okay, so that is vertical angles congruent, is why those two angles there are congruent. All right, so we're working a couple of proofs together. In the questions that you will have on the video, they will be filling in the blank on a few proofs that are not completed all the way for you.